Let's finish this up, huh? Man, you're almost there. You don't have to listen to me talk. So soon. You're almost done with my stupid voice. Oh, it'll be a glorious day. But good on you for grinding all the way through and still watching these silly things. So there's our scenario. We found part A. We found part B. We're just looking to solve part C and part D. We found from part A we got our two parametric equations over here. And then we found out that the ball hits the ground at 25 over 8 seconds, or 3.125 seconds. So let's go see what we need to go figure out. So the question is now asking us, now what is the maximum height of the ball? What's the maximum height? So that's actually asking us, what's y? All right, what's the maximum height? Because the vertical component goes with y. The horizontal component goes with x. Shoot, so we need to know where the biggest y is. This is going to be found in what we call the vertex. Either the tippity top of a parabola or the bottom of it, the peak or the valley. We've discussed in the last one that we're actually talking about a parabola that's facing upside down, at least as y is with respect to time. So let's jump over and take a look. That's why I still have the graph up that I had made from before. So for part C, we want to know what's the max height. Huh? We want to know what's our biggest frickin' y value we could find. What's the biggest y value? Now I drew my crappy graph. I just enlarged it a little bit so we could take a look at it this time. And we're going to say that the tippity top is right up here. That would be the biggest height. This is what we call the vertex. Now there's going to be two different ways that we can go through and solve this. And in the simple case that we have here, the simple case where the height is equal to 0, we can do this little bit of a shortcut. We could use logic. But we can only frickin' do this when you have that the initial height is equal to 0. A parabola has symmetry. So if your initial height is equal to 0, then we could say that it lies right in the frickin' middle of 25 over 8. We know when it hits its maximum height at half. Cut it in half of how long it takes for it to hit the ground, or 25 over 16. So that can at least tell us when. We can just take our answer and go plug it on in, and that's going to tell us what the maximum height is. So if you'd like to just skip right past and not learn about how to do it for every case, you go right ahead. But right now I'm actually going to explain how to do this without just doing the trick. What happens when the initial height's equal to 10? How are you going to solve it then? So here's our concept. Here we go. Let's keep that up. We're going to say that our y, that parametric equation we have is this. But what form this is in? It's like, do you remember this? ax squared plus bx plus c. Remember that? Where this one has a plus 0 at the end. And we're not talking about x's, we're talking about t. So, let me just change it up a little bit. Bang, there it is. It's a parabola facing down. We have all these freaking properties. Did you know? Did you know where the vertex is located? Do you know where the vertex of any parabola is located? That point is always negative b over 2a. It's negative b over 2a. So the vertex is at t is equal to negative b over 2a. That's not going to tell us what the height's going to be, but it'll tell us when that height occurs. So let's take our problem. Let's take this, let's get rid of, and let's define our variables. Let's say, our a is equal to negative 16, right there. Our b is equal to 50, right there. And then our c is equal to 0. Well, shoot. Let's plug it in. Let's just plug it in and see when we're going to have this. So t is equal to So we got to take our b and we got to turn it negative. So we'll be like negative 50 over 2 times, and we put it over negative 16. 2 times negative 16. Well, good news. Those negatives are going to cancel out. I think 50 over 2. 50 over 2, I think that's 25. So I think we end up with 25 over 16 seconds. You ever heard of that? Have you ever heard that number before? 25 over 16? 25 over 6. Oh, so this is a way that's going to work for all cases. This works when h is equal to a trillion. Works for any of them. So what we have not found the maximum height. All we have done is found when the maximum height occurs. So now this is when you want to pop out your calculator. Okay, we're going to take this and we're going to plug it on into our formula right over here. We want to take it, we want to plug in our t. Everywhere we see one in our y value. So this is equal to negative 16 times something squared plus 50 times something, and we pop in that 25 over 16 for each and every one of them. All right, and this is where you'd want to use your calculator. I mean, you can absolutely simplify this down. I can already see the tricks to how to make it work, but I don't know if I necessarily want to. Oh, what the hell, I guess I'll do it. Negative 16 times 25 squared all over 16 squared plus 50 times 25 over 16. Now, you can check me with your calculator. You don't have to do this. I think I'm showing off at this point in time and saying that this is 25. Ooh, shoot. 25 times 25. Oh, isn't that 25 squared? Oh, I'm sorry. I wrote that in wrong. 25 squared over 16. Plus this one is going to be, well, that's actually 2 times 25 squared over 16. We have a common denominator, so I think if you have 125 squared plus a 225 squared, you have 3 times 25 squared all over 16. All right, I'll stop. Now let's punch this thing into a calculator. I think I can handle that a lot better. 3 times 625 divided by 16, and then we get approximately 117 point. Now, what do I want to round to? 2? Let's go to 1. Let's go to 1 decimal place. And we could say that our max height would be 117 feet. And again, you didn't need to do any of this. I just wanted to show algebra that you might need to be able to do in a calculus class. Let me know if I made a mistake. I probably did. So we found out what our maximum height was. 117.2 feet. These problems are beasts, yeah? Lots of parts, but I think it's something you can hold on to. You've seen a ball go in the air and hit the ground, so you can visualize the whole thing. It's just how we go about it. And do we remember things like the vertex can be always found at negative b over 2a if you have a parabola? Cool. And that's where we're going to find our maximum height, is at the vertex. Cool, so we got our part C. Let's see. Wow, my writing's beautiful. Cool. Now, finally, gosh, it was like, why do we even find x? It wants us to determine the horizontal distance of the ball. And to tell you the truth, this is the simplest one. C was the tough one. C was the beast. So we want to determine the horizontal distance of the ball. Crap. How are we going to do that? How would we ever know? But let's go back to this. This might seem counterintuitive, whether we use our t and our y values here. Remember from back here, it goes like this. Don't we know when the ball hit the ground? Didn't we find this from before? When the ball hit the ground? The ball hit the ground at, t equals 25 over 8 seconds. Okay, so 25 over 8. We know that. Okay, cool. So we know when the ball hit the ground, but that's for y's. That's not for x's. So I don't remember what I was saying before I had to pause this, so there might be a jump. Sorry about that. But we're going to look for our x value when t is equal to 25 over 8. And that's merely, you're going to plug it right back into, this is the simple one. You just got to plug it back into your equation here. So our x is going to be equal to 50 times the square root of 3 times that t, but we've already found it as that 25 over 8. So we can just take this thing, plug it into our calculator. 50 times 25 times the square root of 3 Enter, divide that thing by 8, and I think we found out that this is approximately equal to 270.6 feet. Wow, sounds like dude can really freaking hit the ball, unless you think about that. If you think about that, we typically talk about it in yards, and that's not even 100 yards. Dude, I think even your gangly teacher could actually hit a ball that far, and I suck at golf. So we found part D. There it is. We're finally freaking done. Are you excited? Are you fired up? Let's make certain that we get this stuff down. You're going to need to get your practice throughout your homework. And again, it's going to show up on your test. So good luck to y'all. Who knows? Maybe in class, or maybe in another video I'll do one where the height is not equal to 0 and we can run through it. So good luck.